Today I will be explaining the daily Leetcode challenge problem, maximum width RAM. The problem description is as follows. We will be given with an integer array called nums. We have to consider a pair of indexes from the array. The first index represent I, the second index represent j. The condition of the I and j is as follows. I should always be less than j. And the second condition of the problem to calculate the ramp is nums of I less than or equal to j. Okay, if the two conditions are satisfied, then the width of the ramp is calculated. The formula for width of the ramp is j minus I. We have to return the maximum width of the ramp. If no values satisfying the condition, then we should return the value 0. The explanation of the question is as follows. Consider an array of elements 1, 2, 3. The indexing is 0, 1, 2. The question has two conditions. The first condition is I should be less than j. The nums of I should be less than or equal to nums of j. If these two conditions are satisfied, then the ramp will be formed. Ramp equal to j minus I. Maximum ramp should be formed. Let us assign the maximum ramp of value 0, as there is no finding at the moment. So the pairs that can be formed for this array is 0, 1, 0, 2, 1, 2. Let us consider 0, 1. 0, 1, 0 is less than 1. So the first condition will be satisfied. 1 less than 2. The second condition is also satisfied. So the ramp is 1 minus 0. Now the ramp value is changed to 1. Okay. For the condition 0, 2, this also satisfies the condition 1 and 2. So the ramp will be changed to 2. The pair of 1, 2, this also satisfies the condition 1 and 2. That is 1 is less than 2 and 2 is less than 3. So the ramp will be calculated j minus a, that is 2 minus 1. 2 is greater than 1. The ramp will not be changed and the ramp will automatically return 2. If there is no value found, the default value of the ramp will be 0. I will be solving this problem using a stack. Let us consider a stack of elements of null. So initially the pointer points here. The peak is here. There is no element. The array given in the question is 608215. So the 6 will be checked with 0. The first condition, that is I minus j, will be satisfied. Nums of I minus I less than or equal to nums of j. Okay, this condition will be failed. The 6 will be checked with 8. Both the conditions will be satisfied. So m is 2. The condition will be checked for 6 and 2. This cannot be done. Now the 6 and 1 cannot be done. 6 and 5 cannot be done. So the operation goes to 0 and 8, as we should not check the previous elements. As the first condition states, I should always be less than j. If the pointer I points the current element, the j should be one of the next element. So next element pointer. So 0, 8. 0, 8 satisfies first and second condition. The m will be the ramp will be 2 minus 1. 1 is less than 2, so 2 will not be changed. Ramp value will not be changed. Okay. 0, 2. The ramp value will be 2. The ramp value will be remained the same. So 0, 1. The ramp value will be changed to 3, as we got a found which satisfies two conditions, as 0 is less than 1 and nums of I is less than also j. The 4 minus 1 will be 3. Again the ramp value will be changed to 4, as 0 compared to 5. 0 compared to 5, 1 less than 5 if the first condition is satisfied. 0 less than 5, the second condition is also satisfied. So 5 minus 1 will be 4. The maximum ramp value up to now is 4. Okay. Afterwards 8 comma 2 cannot be done. 2 can be done only with 5. 3 minus 5 is 2. 4 will be remain the same, will not be changed. 1 comma 5, the ramp value will be 1. So the maximum ramp value that can be calculated is 4 here. Okay, so the intuition of the problem will be as follows. I will traverse array in two directions, one from the front and another from the backwards. Initially, the 6 for the value 6 will be directly pushed into the stack. That means the index of the 6 will be directly pushed into the stack, and we will be checking with condition nums of peak of the stack. That means the top point of the stack will become into considered as peak. Nums of peak greater than the current value nums of I, then the I will be added to stack. 6 will be, so 6 is greater than 0, so the peak will become 1 now. 0 will not is not greater than any of the values, so current peak of the value will be remained as 1 itself, the index representing the 0. Okay, now we will be checking each value. Nums of I last value is greater than or equal greater than or equal to nums of stack peak value. Nums of stack peak is 1, nums of 1. If true, the m will be updated, become 4 now. For this, there is no maximum, m cannot be find greater than 4. This will be the approach. The coding part of the problem is as follows. I am implementing a stack of integers. I am using Java as my programming language. If no value is found satisfying the both conditions, the max value will directly remain as 0. Okay, okay, thank you for watching.